Picking PC parts suck when you don't know what to look for, but I'm going to make it so simple in this video that even a 10-year-old could build one. By the end of this video, you'll know exactly what parts you need for your perfect PC. So, let's get into it. At some point, you've probably wanted a PC, because it's that one thing that everybody has that lets you do anything, from gaming to editing and creative work. Everybody wants to have a PC, but buying a pre-built is often overpriced and isn't worth it. So you decide to build it yourself. But to do that, you need knowledge, which as a beginner you probably don't have. So today, I'm going to explain simply how to pick components that work well together and suit your needs. Step 1 is define your mission. The first thing you need to figure out is what this PC's main job is and what you plan to accomplish with it. Answering this will instantly tell you where the bulk of your investment should go. Generally, you have three main categories. High performance, so this would cover serious gaming or heavy duty creative work. Then you've got balanced use, this is for casual gaming combined with productivity. And then you've got basic tasks. This includes simple work like browsing the web or doing homework. And step 2 is slice the budget. Once you've defined your use case, your next step is to portion your money between all the necessary components. A PC needs 8 essential parts to function. Let's look at their roles. The processor is like the team manager. It directs the workflow and tells every other part what to do. Then you've got your graphics card. It's the visual storyteller. It creates all the images and frames you can see on your screen. Then you have the motherboard. It's the grid, a massive circuit board that lets all the parts plug in and communicate in sync. And then there's RAM. It's your computer's short-term workspace. It helps your PC juggle multiple tasks at once. Then there's the power supply. It's the power plant. It takes electricity from the wall and safely distributes it to all of your components. Then there's storage. This is your computer's permanent library, keeping all of your files, games, folders, and operating system safe. Then there's the case. It's simply the housing, or the shell, that holds all your components securely. Then finally, you have the fans. These are the climate control that keeps everything from melting down under heavy use. Now you know what you're buying, but don't rush to checkout. You must now decide your budget for each part. Let's say you have $1,000. If you blow all your money on a powerful graphics card, you won't have the funds left for a decent CPU to feed it data. You have to divide that total budget into strategic tiers. Here's a simple guideline that shows a percentage range you should aim for. Let's say for a processor you should spend 20 to 25%, so that would be $200 to $250 out of your thousands. Then for your graphics card you should spend 30 to 40%, or $300 to $400. Then for your motherboard you should spend 10 to 15%, or $100 to $150, and so on for the remaining parts. These numbers are totally flexible. If you prioritize 4K gaming, you can pump an extra 5% into the graphics card and take 5% from somewhere else. This initial breakdown is just a solid starting blueprint for planning. But the number one top tip is do not try to save money on everything, especially the power supply. If you cheap out on this, a faulty unit could experience a critical failure and take your entire build with it. You risk frying $1,000 worth of components. But don't worry, I'll break down how to choose each part so everything connects and performs together with precision and stability. Step 3 is to match your core components. Choosing components that work together is key for a smooth build. The first parts you must pair are the CPU and the GPU. But which one should you prioritize? Well, for work and productivity, prioritize the CPU. Software like video editing and rendering relies heavily on the CPU's ability to perform calculations. The CPU determines the physics and the geometry, the GPU simply makes it look good. But for gaming, prioritize the GPU. This component has the biggest impact on frame rate and visual quality. To ensure they're matched, they should work in harmony. A common sign of imbalance is called a bottleneck, where one part, often the CPU, can't feed data to the other part, like the GPU. You can check benchmarks on YouTube. If the GPU usage is constantly near 100% whilst the CPU is working hard, they're well matched. You can also use an online bottleneck calculator, where there's a link for that in the description, to test a potential pair. While these calculators aren't perfect, a result over 5 or 10% might indicate a mismatch to research further. You can even ask an AI like ChatGPT for feedback on a specific CPU-GPU combination for your chosen game. But how do you understand these CPUs? Two giants dominate the market, AMD and Intel. AMD names their things in tiers, like Ryzen 3, 5, 7, and 9. And usually, the higher number means better performance. Intel does the same, with tiers like Core i3, i5, i7, and i9. Same applies here, higher number equals better performance. Then there's generations, like a 4-digit number, like 5000 series, 7000 series. A newer generation model often beats an older, higher tier model. And then with Intel, a 2-digit number is usually their generation, like 12th generation or 14th gen. Also newer is generally better. But now that you understand CPUs, you must understand graphics cards. Graphics cards are simpler, they are the easiest components to choose. Check benchmarks in the game you want to play. Like Nvidia uses series numbers like 20, 30, 40 and 50, and a model number like 50, 90 and 40, 80. AMD uses a similar tiered numbering system, and Intel, the newest entry, uses A numbers. Comparing the latest generation's mid-range cards, like a 5070, to the previous generation's high-end card, like a 4090, will quickly show you which one delivers the best value for your needs. And step 4 is all about the motherboard. The motherboard is all about compatibility. Once your CPU is chosen, your motherboard must match it perfectly. So the first thing you need to do is filter by a budget. Select a board that fits your allocated 8 to 12%, and then you have to filter it by socket. The socket is the physical component where the CPU installs. AMD typically uses AM4 or the newer AM5 sockets, and Intel usually uses LGA sockets, like LGA 1700. Your CPU specs will list the required socket type. And the third thing you need to do is choose the chipset. The chipset is like the brain of the motherboard, defining its capabilities, like overclocking support, port availability, and etc. AMD's chipsets come in A series, B series, and X series. A series is basic, no overclocking, and is best for office and browsing builds. B series is mid-range, decent features, it supports overclocking, and is great for most builds. And X series is premium. It comes with everything unlocked, only necessary for extreme or high-end custom builds though. And Intel comes in H series, B series, and Z series. H series is basic, not recommended for serious gaming. B series is mid-range, and is a solid option for most balanced systems. And Z series is premium. Comes with a full feature set, necessary for K series CPU overclocking. Let's also verify the motherboard's maximum RAM support and speed to avoid wasting potential. And now step 5. We're going to be explaining RAM, power supply, your storage, and your cooling. So let's start with the RAM, which is your temporary workspace. Firstly, quantity matters. 16GB is the absolute minimum for modern gaming, but 32GB is the new standard for serious builders. Then you have configuration. Always use 2 sticks in dual channel. 2 8GB sticks are much faster than 1 16GB stick. And now you've got speeds, which is measured in megahertz. The higher the frequency, the better. Match this to your motherboard's limits. And then timing, which is measured in CL. Lower numbers are better, but do not overstress the spec at all. Moving on to your power supply, the heart of the PC. This is the most critical safety component. The first thing you need to do is calculate wattage. Use an online power supply calculator, like the one in my description, by entering your CPU and GPU, and it will give you a result of which power supply wattage you should buy. And secondly, add a buffer. Take your calculated wattage and add 100 to 200 watts to it for safety and future upgrades. And then check the efficiency rating. Buy a power supply that is rated at least 80 plus bronze, silver, gold, or platinum. They're better and more efficient than anything lower. And finally, use a trusted brand. Stick to known reputable brands that are widely used. Buying a cheap Chinese brand will almost always end badly. And moving on to storage, which is the library of your PC. Always prioritize solid state drives over older hard disk drives. The speed improvement is massive. Firstly, faster is better. You've got to look at the read and write speeds listed in the product description. And then there's types. If your motherboard supports it, choose NVMe SSDs. They are significantly faster and plug directly into the motherboard. Otherwise, use standard SATA SSDs. And then you've got your cooler, which is the AC system. You have 2 options, air coolers, which are cheaper but sometimes noisier, and liquid coolers, which are better performance, often quieter, but they're more expensive. The first thing you need to find is your compatibility. Check your CPU's thermal design power, which is the heat it produces. Your cooler must be rated for a thermal design higher than your CPU's. That's the only real rule. And finally, your case, which is the shell. The first thing you need to do is find your budget for it and spend the allocated 3 to 5%. And secondly, the fit check. Ensure the case is compatible with your motherboard size, like Mini ITX, Micro ATX, or ATX. Also check the maximum allowable GPU length and cooler height. And finally, check for power supply location. Try to get a case where the power supply is installed at the bottom, as this is better for cooling efficiency. Hopefully this structured guide gives you the confidence to pick perfectly matched parts on your own. But remember, treat your PC like a system where every part matters and you'll build something great. Well guys, I hope you enjoyed the video. Please consider liking and subscribing. And if you enjoyed the video, let me know in the comments down below what you thought of it. I read all my comments. But without further ado, I'll catch you in the next one. Peace out.